Cool. Okay, welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by APAC OUC. This year, our event would be the biggest one ever, with 174 sessions, that's including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages, so please remember to register to as many sessions as you can. And all sessions would be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. Now, I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Oracle Cloud Development Deployment by Stefan Oehrli. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Stefan. And I do hope I pronounce that surname correctly, Stefan.
Yeah, that's perfectly.
Cool. Okay, take it away then.
Okay, welcome from my side. Good morning from Switzerland. I think it's good afternoon in APAC time. I'm going to speak today about cloud deployment with Terraform. First of all, about a few information about me. I work as a platform architect and trainer at Trivadis. It's a consulting company located in Europe, in Switzerland, Germany, and Austria. I do work in various IT areas since 1997, and I work for Trivadis since 2008. So I have a bit more than 20 years of experience with Oracle databases, and mainly operational work, security, backup recovery. During my past weeks, months, I start to work closer with Oracle on cloud, in particular with deployments, cloud deployments for our training environments, and that was the point where I start to use Terraform. Trivadis itself, as mentioned, is a company in Europe, located in Europe, founded in 1994. We are spread across Germany, Switzerland, and Austria. And main focus is to work on database technologies like Oracle, Microsoft, on-premises and cloud-based solutions. So that's it from me, from the company, regarding me and the company. I would like to start more detail with my presentation. I have a short agenda. We're going to make a short introduction why we do discuss this topic. I will give a short introduction into Terraform. We then discuss the first step, how to use it. Next step, use cases, how we could enhance and start to use Terraform for more complex environments. I will also discuss a few good practice and provide you some further consideration and finish my presentation with a short summary. So let's start. There are different methods to provision resources in clouds in general, and in particular also in the Oracle Cloud. The first introduction is usually when you start using the OCI console. You have a picture here on the right side, which shows my console of a compartment called OSEC. You can access it via browser. The URL now is the one for the Switzerland-based Oracle Cloud. The downside here is that it is GUI-based, so it's an advantage. It's GUI-based. You can view things. And on the other hand, there is no automation. So you cannot create automation based on the web GUI. Therefore, Oracle provides other methods to access the cloud resources. One solution is the command line interface, so OCI SDK. Oracle also has REST APIs, and they do provide several SDKs for command languages like Python, Java, etc. There is also an Oracle Cloud Infrastructure shell, which you can use to access your cloud information. But altogether, there's just no to moderate the automation. I mean, basically, you can use the SDKs and the REST API to do automation, but you will end up that you have to program whatever you want to do. So it is time consuming. You have to define every step which you want to implement on the cloud. I once did this and build up an OCI-based training environment, means compute nodes, network configuration, network components, etc. Everything with OCI. And I have to care myself what kind of resource I did create, when I did create which resource, and how do I reference this resource to another resource. So it was quite time consuming. I did use CLI, so the OCI CLI and Bash, which is also not really the best idea. It would be a bit more simpler when you use the SDK with Python or something else. But nevertheless, you have to program every step which you want to implement in the cloud itself. On the other hand, we have the keyword, the known word as infrastructure as code. So you want to define your infrastructure, some kind of a descriptive model, and apply it and provision it in the cloud, so that you can generate the same environment from the same source code. It's a key concept for DevOps, and it's quite common. There are several popular ISC tools available, like Chief, Puppet, Ansible, SaltStack, Cloud Foundation, and Terraform itself. They have different use cases and different fields of application, and not all can be replaced with each other. Some of them, they are help each other to fulfill the target, but they cannot be a one-to-one replacement. We'll discuss this a bit later on more detailed. So now what's about Terraform? What's this exactly? Terraform in a nutshell is, I have on one side a planet, and on the other side I have a Earth, or a Earth-like planet. And terraforming means bringing a planet somehow to an Earth-like environment. This is Terraform as we know it from the past, as we probably know it from science fiction movies, science fiction stories. So I mentioned this like this, that Generation X, they know, Terraform, that's something to alter an environment, to make it more Earth-like, and to implement terrestrial life forms. Pure science fiction, really known in books, films, movies, etc. You see on the upper right side the picture from Total Recall, where they terraform the Mars environment. Terraform for Millennials is a bit more something different. It is an open source software developed by HashiCorp. It has initially been released 2014. Currently we have a stable release 0.13.4. I think it's in the meantime it's 0.5, as I checked it before. It is a tool which is focused purely on infrastructure as code. It is using a declarative configuration language. So I'm going to describe my environment with this language, and Terraform itself then takes care that this environment is provisioned to a cloud. Terraform itself is purely open source, and it is written in Go. You can browse it. You can look into the corresponding Git repository. So altogether, Terraform is a tool to build, change, and versioning your infrastructure safely and efficiently. So that's all. To use another quote, one ring to rule them all. One idea is, or Terraform itself is a separation level. I'm just missing the English term for your infrastructure. So you can describe your environment. You don't have to implement the exact procedure to implement it like you would do it with a procedural language. But on the other hand, it is not generic. So it is always tied to a specific cloud environment. So you cannot build generally a Terraform configuration where we define your network and your compute resource and other components, and then deploy it on any kind of cloud like AWS, like Google, OCI, Azure, etc. So Terraform itself, it's called cloud agnostic. So each configuration is bound to a dedicated provider, which is then bound to a dedicated cloud. Terraform itself keeps the state of the infrastructure maintained in some kind of a state file, and it uses a plan and a plan to generate your infrastructure. So first you define your infrastructure in your configuration, and then you're going to use a plan, or you're going to create a plan with Terraform to how to apply this infrastructure on the cloud. And then last but not least, you then can apply and provision this environment. We see this a bit more in detail later on. Terraform itself is using configuration language developed by HashiCorp. As mentioned earlier, the language is describing your goal you want to reach with your infrastructure, and you don't have to consider the detailed steps to reach this goal. So you don't have to care about, do I have to create first my VCN and then my gateway and then my load balancer before I can create my host and database. So this is handled by Terraform and the corresponding provider. We have another component, or one of the main components in Terraform is the provider. The provider is responsible to understand the API of the corresponding cloud provider. So it is it's filling the gap between Terraform itself and the cloud provider. And it tells Terraform how to build and manage one or many resource type in this particular cloud environment or in this particular environment. The provider itself, they are available directly within Terraform, respectively from the Terraform Registry, or on GitHub. You see the corresponding GitHub repositories for the Terraform providers. Beside providers, we have other components called modules. Modules are containers for multiple resources which are kept together. So it can be used as an abstraction layer that you want to keep things together which belongs together, or that you want to define infrastructure resource which you often reuse yourself. We see this later on. The modules itself are also in the Terraform registry. They can also be local or in the version control. Then we also have the backends which are used to store the state. These are either local in a text file, or could be different kind of backends like OCI object store and so on. Here a short view of the Terraform registry. You see the providers. So the main providers which are available and mainly used are highlighted in coral by Terraform itself. That's the AWS, the Azure, Google Cloud Platform, Kubernetes, Oracle Cloud Infrastructure, and Alibaba Cloud. These are providers which are developed by HashiCorp. There are for different environments, also other providers as well. As mentioned, providers are either supplied by HashiCorp, a resource provider, a third-party provider, or by the community itself. So if you have your own environment, your own use cases, feel free to develop your own provider written in Go and add it to the environment. The provider itself are either integrated, so they will be automatically downloaded by Terraform when you need them, or not integrated if it's your own or third-party provider, which you can install manually. Oracle itself, for Oracle itself, there exist 3 different providers. That's the main provider for the Oracle Cloud infrastructure. Then we also have the Oracle Cloud Platform Provider, and we also have the Oracle Cloud Infrastructure Classic Provider. I would say the current one which you should use when you start working with Oracle Cloud is definitely the OCI provider. The Oracle PaaS is somehow legacy, and the OPC, so the classic provider, is definitely a legacy and shouldn't be considered for new projects anymore. Here's just a print screen of the OCI provider. The important thing, if you go through the registry, you see on one side, in the middle of the picture, the URL of the source code. So it's worth having a look there, in particular because you will find quite a lot of examples in the provider itself, in the GitHub registry, GitHub repository. And on the other side, on the upper right side, you have the link to the documentation, which explains the different resource and data source which you can use with this provider. Again, with some examples and etc. I can show you this shortly. So we have the Terraform registry. We can go to the provider, Oracle OCI provider. I mentioned here the source code. Really important and interesting is here the example section, because below this, or in this subfolder, you find plenty of examples how you could use the Terraform OCI provider. Like you can go to set up a compute image, and then you see the corresponding configuration file, how you would have to use it, and how you would have to create a compute resource, a compute instance within OCI. Besides this, it is good practice to subscribe to the issues so that you get informed when there are issues and information on the OCI provider itself. Then the other link is the documentation. That's something which you should use day by day when you work on OCI and Terraform, because you find information about the provider itself, how you use it, but then also about the different resources. If we go to core resources, we see then, for instance, the Oracle core instance, and then you have all the information how to use it, example usage, parameter which you can use, etc. So that's a must have and a must view when you work together with the OCI. To clarify a bit, distinguish a bit from the other tools, Terraform itself is used to create immutable infrastructure, means they are created and not modified. You describe your infrastructure, rather define the procedure, how it is provisioned. It's also declarative. And it is focusing on provisioning it, and it's not a configuration management tool. So you do deploy version X on your environment, and if this changes, you define version Y and deploy the new version. So you do not upgrade, and this has some impact. You have to make sure that if you have persistent data, that this persistent data is not in your infrastructure, or that it is stored somewhere else, and etc. Because the Terraform itself does not upgrade your infrastructure. So you always create a new one or replace the existing one. There are alternatives to Terraform, tools like Ansible, Puppet, Chief, for instance. They build mutable infrastructure, so you define your infrastructure, you define the procedure to set it up, and you also define if you want the procedure to upgrade it. So if you have version 1, you can create then version 1.1, 1.2, etc. So in most cases, it is a procedural approach, and it is a bit another approach compared to Terraform. In particular, it usually makes sense to combine Terraform and other tools. For instance, that you define your infrastructure using Terraform, so you build your infrastructure, and you use tools like Ansible, for instance, to then deploy your web application, your database configuration on top of the defined infrastructure. And these tools are then also used as a configuration management of your environment. So let's start with a few first steps and let's see how we can use it. First of all, you have to install Terraform. Terraform is available for common OSs like Linux, Mac OS, Windows, Solaris, etc. I can recommend you you use the latest stable releases or stable release, which is 0.13. In particular, it does introduce a couple of features like support for loops and count in Terraform models. If you use macOS, you can use brew or homebrew just to run brew install Terraform, and a couple of minutes later you have it. You basically don't have to install anything else, so you don't have explicitly to install any any OCI Terraform provider, because this will then be installed if you start using it. But what you have to do when you use Terraform together with OCI, you have to configure the access to OCI. Means you have to define the credential and set this up. So first of all, we have to create an RSA key locally, which we can store then in OCI. So you can use OpenSSL or any other tool to create the RSA key in PAM format. The public key then has to be copied to the Oracle Cloud. So in the user setting, API keys, you have to add your keys. Beside the public key which you created, you have to gather some information from OCI Console itself. So you have to gather the tenancy OCID, the user OCID, the fingerprint of the public key which you just created and uploaded, and also the region where you want to work on. This information then has to be stored in a Terraform configuration. So if we work with Terraform, you create a folder, you create your Terraform configuration files in it, and one of these files has to include the information how to access your cloud environment. I have here an example. You see the OCI, the tenancy information, fingerprint, etc. For testing, this might work, that's okay. But if you start to put things in version control, if you start to share your code with others, if you become productive, it's not really a good practice to store all your credential information in OCI configuration itself. Even if your colleagues probably do not have your private key, it is probably all other information are stored there. So you can change this slightly so that you don't use the values itself. You define variables. We have here the same block again, provider OCI. I replace the values with variables. And below we see then that I use a dedicated variables file, and in the variables file I define the different variables, OCID, etc., the fingerprint, private key, etc. But in the variables file, again, I don't add the values. You then can add the values in two ways. You either use a Terraform vars file, so a text file where you add all the values for the different variables. here you see an example for the region. As I said, region equals EU Zurich 1. Alternatively, and that's really a good practice, is that you start using environment variable for your dedicated variables. In particular, the logon and credential variables. The variables and the environment variables are prefixed with tf_var. So if you have a Terraform variable called fingerprint, the corresponding environment variable is tf_var underscore fingerprint. So this way you can keep your authentication information separate from your Terraform configuration, and you can also use it for different Terraform configuration. So as soon as we have this configured, we can start to initialize the Terraform configuration. If you do a Terraform init, Terraform will create a hidden folder .terraform and download all the required providers and modules. You can then validate your configuration, apply the plan, set up the plan and apply the plan to the cloud. If I do this, I can show you a short example. I have here an example with a few Terraform files. I do a Terraform init. It does update my backend. I can do my plan. And you see then it provides me information what it is planned to do. So in my case right now, I have no change. I'm going to remove my state file. So I do the plan again. And it then, you see, it calculates something. It calculates this plan. And for this plan, it is using these resources, a quite simple stage. It does update the state file or create a state file. Create a plan file, and this plan then can be applied. And now Terraform starts to implement the plan. Here we see in green text, the green text is the output of my plan, or the result. You also see what has happened. So no resource was added, no resource has been changed, and no resource has been destroyed. Why exactly, or what's in here? You're going to see it right now. I just create a simple data source in my OCI, in my Terraform configuration. So I just define an OCI code image, add a few parameters, and I just use this to query information from my OCI. So I define this data source, and I also define a result. So the result, the output, is then shown in green text as before. So if you do more complex stuff, then it also creates the corresponding resources. So if I show it here in the other example, I have a Terraform init here again. I do my plan. It's a bit more complex. You see here, it does consider a couple of modules and a couple of other resources. Have no change now here. Change a Terraform variable. Do again a plan. And in my situation now, we're going to see, oh, suddenly I have a bit more. And now we see, if I scroll up, there is quite some information. Quite a lot of information. And we see here, it will create a couple of resources using models, but also directly without models. And at the end of the day, we see it in the next slides, it will create an additional training environment. Here is the details of the plan. So 15 resources will be created, none will be changed, and none will be destroyed. And the change output is then provided here. So that's the output which will be shown as soon as I provide or apply my plan. I will have information about DNS records and host names, VCNs, etc. We have here, for instance, if I take this output, I have an output called Bastion private IP. I have a value, and then I have a plus, which means I already have this kind of resource, and my plan is currently creating another one. That's why there will be then a new environment. I'll show you a picture of what happens when you apply this plan. So I apply this in the background. Oh, I think I have to hurry up a little bit. So here again, the slides with the resource. So if you start, then you usually don't define the resources as I did in my example. So simple core image resource. You would like to create real resources in the cloud. So then it's time to have a look into the provider, what kind of resource you can configure. For instance, a core image, an OCI instance, autonomous database, and any kind of other resources in the Oracle Cloud. If you then start to build things, it's really worth to start with small steps, that you start to create small resources and to combine them if necessary. Configure, you even can go the way that you configure manually a VCN in the cloud before you immediately start to implement it in Terraform, and just reference to this VCN and just create the compute instance in your environment. So in your Terraform configuration, and then go deeper and deeper and enhance your configuration step by step. Another thing which you have to consider is that you have to try to avoid huge environment. So it doesn't make sense to have a huge Terraform configuration which rules them all again, and because it's getting cumbersome, it's difficult to find resources and etc. It's also a good tip to consider modules. So define a reusable infrastructure component, as I did. And we see it when you switch back to the Terraform. Modules itself can be defined really simple. At the end of the day, you just define the input variables, output variables, and resource which you want to create. So that's the minimum. Usually, you define a root module by defining a folder. You add a README file. You add a main Terraform text file, variable file, output file. So the name or not doesn't matter. It's just best practice that you name the main variables and outputs. If you just have the three of them, that you know, okay, my outputs are defined in the output text file, variables are defined in the variables file. But at the end of the day, Terraform doesn't care. They just read the TF files and go for it. And it's also good practice that you add examples how to use this module. Modules itself then looks like this way that when you use them, rather than defining the OCI resource, you define the lab. The source of the module. This could be either a local folder somewhere on your file system, reference from your local Terraform configuration. So I define a module called lab compartment, which is one folder above my current folder. And I have to define the input variables. In this example, it is the compartment name and the base compartment OCID. There are other locations for modules like the Terraform Registry, GitHub repository, Bitbucket, etc. Terraform itself will download and copy these modules to your local configuration if required. You see here a module below which I add a source from Terraform Registry. So the source is Trivadis 3D Lab VCN OCI, so that's a naming convention defined by Terraform, and Terraform itself is looking up this module in the Terraform registry. It can also be any kind of other resource, like GitHub and it has slightly different source attribute. Here, this is, you see this Terraform registry. For this module, you have the version. You also always have then a simple documentation, output value, input value, dependencies, so that you really can start using it and make it easy for others to reuse your module. I did create a couple of modules called DVD Lab Base. They are based and inspired by the Oracle modules. They have a slightly different approach because compared to the Oracle module, they provide the count support. So you can add a count value, and then it will create n number of Bastion host, DB host, VCN, etc. The intention for this is that it is used to create training environments, so that I have one set of Terraform configuration for a training environment, and that just can define and let Terraform know, so please create me not one environment, please create me 10 environments of the same type. It does look like this, so this configuration, it creates a compartment, it creates a VCN, and within this VCN, a couple of resources like routing table, gateway, NAT gateway, internet gateway, Bastion host, and the DB server. And since this is defined as a module, I can easily create multiple environments like this. Just to show it shortly, yeah, it is probably easier when I show it here. If you browse the modules, you see the base module, the documentation, the dependency. So it itself uses other modules to create the Bastion host, the DB host, or the VCN. It has a couple of requirement of input variables and a lot of optional input variables to configure your environment. And if you see in the source code, this is based of a main file, output and variable file, and this is used to set up this environment. It does itself has some examples, so if you want to use it, it shows how you use it. At the end of the day, if you have your own environment where you want to use this model, then you see, I have to add the module and the source of this module, and then you have to provide a certain amount of information, and then I can use it in my projects. So it's a bit, we soon are running out of time. I have a few other pictures about the environment which you can set up. You can extend this then and do this, and we use this for setting up our lab environment at Trivaris. Here you will see again the folder, and it's a bit similar as before in the website. Just to finalize my presentation, a few good practice which I would give you is that if you start Terraform, try to start it really early in your OCI journey, because then it's already part of it. Make sure that you use a version control to store your configuration, ideally a separate repository for each configuration modules. Then also an important part is store your state file centrally, because it's crucial. If you have it locally and your colleague wants to set up the same or update the environment which you have defined in OCI, and he doesn't have the state file because it's on your local PC, then it may end up that he screw up the configuration. So if you store it centrally in in an object store, Terraform will access always the same state file for this environment, and you can make sure that from everywhere you run it, you have the correct and the correct state. I mentioned this already. Use the latest version of Terraform. It is regularly updated. Currently, we have 0.14 in beta. I think it will be soon released as well. Try to keep your Terraform configuration simple. Create multiple files, which makes sense, so that you have a Terraform configuration file for your compute instance and probably one for the network, and not everything in one file. And also be careful when we rerun apply. It happened to me a couple of times that I changed the Bootstrap configuration script, and at the end of the day, it recreated my compute instance, which was not the plan. And that's a danger. If you have infrastructure as code, if you do fast apply and deploy, there's a risk that you can destroy your environment. So that's also another good practice. Don't use auto-approve or force, which means that if you do certain things, that it will apply change without asking you. So it's really crucial that to avoid this, to make sure that you have control over the applying. It's also important to have a clear strategy when to use Terraform and when not, and probably combine it with HashiCorp Packer, Ansible, or other configuration management tools. And it's also important that you update your OCI provider regularly, so that you don't use an old OCI provider. It will be updated regularly, so that you have to do a Terraform init on a regular basis. Make sure to use tools like Visual Studio Code and subscribe to the Terraform OCI issue to get informed when there are things to change. I run out of time. Further configuration are quite straightforward. A few things: you have the possibility to visualize your Terraform environment with Terraform Graph. You can even rediscover your setup. And you have a Terraform Console, so where you can interactively check your state file. So there are a few things which you consider as well. And one thing, also an important thing, is that OCI itself use Terraform to build stacks. So if you use Resource Manager and you want to build a stack, you can do this based on your own Terraform files or pre-built Terraform configuration, and even can specify GitLab environment or use an existing OCI environment to discover it. So these are a few things which you have here. Where to start? Terraform provides a bunch of e-learnings and documentation. Oracle itself has development documentation for OCI, which includes Terraform setup and configuration. And a really helpful source is the different GitHub repository with examples. So the OCI provider with its example, and the Terraform registry for the models with examples. So last page. Terraform is a useful tool for implementing ISE with OCI. It's essential that you have a clear strategy when you want to use what. So you cannot have a configuration to rule them all. So it has to be in certain slices and modules. Consider combining modules for configuration which can be reused. And it is worth having a look at the different resources at Terraform and Oracle to get some ideas and examples how you could build up your own infrastructure. And anyway, if you run Terraform and you create 20 compute instances, it's also good advice to have a watch and look one of these old SF movies and TV shows which show the terraforming in some other way. So thanks for your time. I hope you could get some information how you could start using Terraform on your OCI environment. that's it from my side. As said before, I'm available via mail. You can still ask me. The video is recorded and the presentation will be provided as well online.
Cool. Thank you, Stefan, for sharing your knowledge with everyone. And do we have any question? If you have question, feel free to type your question in the Q&A tab. Yeah, we have one question, Stefan. It says how we can integrate Terraforms and Ansible.
Yeah, this is, I would say, how simple it is. Simple in terms of there are corresponding templates available to integrate Ansible and Terraform. So there are Terraform templates for Ansible are available, and it makes sense that you use Ansible to provide basic configuration of your resources which configured in OCI, so that you use Terraform to build up the infrastructure, and then you use Ansible itself to deploy or to configure the resources. And therefore you can use these templates, and you can even start the complete job from Ansible. So you configure Ansible that it creates the you use Ansible to deploy your Terraform configuration on the first place, and in the second step you use other Ansible templates to provision the database server, to configure your Oracle database, etc., etc. I haven't provided the links, but there are example templates for Terraform available, for Ansible available.
Yep. Cool. Okay. I guess we don't have enough time for more questions, but yes, you can always send question to Stefan through the Groundbreakers website. And I would like to say thanks for everyone for joining this session. The conference is just one day to go, but you can still register to the upcoming sessions. And yeah, enjoy the rest of your day and have a good day.
Thank you. Bye.
Thank you.